Okay, hi everyone. I'm Jana Finch. Thanks for joining us for today's webinar. For those of you unfamiliar with Cloud Institute, here's your 10-second commercial. We are a cloud training company. We deliver cloud certification training and cloud coaching to help developers, solution architects, engineers, and other IT professionals. We are really committed to making sure that you and your teams learn, make sure what you learn in the classroom transfers to the workplace. So we also provide challenge labs and also personalized cloud coaching to make sure that you and your teams reach your goals. Today, we're presenting Internet of Things Primer and Digital Transformation 101 with David Mantica. David is the VP and General Manager of SoftEd US. He is, which is an agile training and coaching company. He's also Cloud Institute's own fractional COO. He has spent a great deal of time in the IoT space and knows how to bring IoT strategy into the business. So one bit of housekeeping, feel free to ask questions in the chat box and or to me privately. We'll answer them as we go, or what we don't get to, we'll cover at the end. We'll also leave a few minutes for Q&A at the end. And later on, in a couple hours from now, you should receive a replay of this webinar in case you need to rewatch or share with your colleagues. So he has a lot to cover. Without further ado, here's
Jana,
David.
thank you so much. Welcome, everyone. So glad you could participate in this. Like Jana was talking about, I love feedback. I love thoughts. I love additional ideas. So please don't hesitate to throw your thoughts, throw your ideas into chat. Share your knowledge, kind of like a wisdom of the crowd concept. Share your knowledge with others. Be able to engage in the presentation. Think about it critically and add value. That's the best part, to get engaged, add value, think creatively, and we can share that information with each other. So the agenda, you can read the agenda itself. So what I'm going to talk about is a couple of things on this agenda. First, a lot of what I'm going to dig into ties back to my experience with Revive Technologies. It was a wearable device to help people with attention deficit disorder, and they are morphing now. So I'm going to talk about where we started, where they morphed, and how that ties into IoT, because it was basically a wearable IoT device. So that's the first thing. Yeah, Paul, it is. They still sell it, www.revivetech.com, or just type in Revive Technologies. So basically, what we want to be thinking about is that this is about digital transformation and digital disruption. I'm going to talk tech, but I'm also going to spend more time around the mindset, the business models. Why are we doing this? So that you can have that why. I want out of this presentation for you to be thinking about the why and not so much the how. And that's part of what we're going to dig into. But as it relates to IoT, marketing is IoT is huge. The data that's being gathered, the data that's being utilized, and the information that is rocking and rolling out there. And that's part of the digital disruption. Then cars. IoT in cars is growing rapidly. The ability to provide real-time information to us while we're driving. We have tools like Waves or Google Maps, but a lot of those are self data that's put in by others. It's not real-time, real data that's coming at you, where you hopefully at some point in time will be able to get gas prices at the upcoming exits. You'll be able to know which restaurants or which fast food places are busy or not busy. There's so many different things going at the car level. On the manufacturing level, that's the industrial IoT. That's been growing, where you have self-healing, self-managing machines, where they can figure out what their software problem is. They can keep up with their warranties. They can keep up and see when there's a diagnostic issue and be able to send out requests to specific repair organizations if things need to be repaired in the system itself. And GE does a lot of work in that environment. On the legal side, IoT is being utilized to replace certain positions within the legal field. Sales with the CRM system Salesforce, that's more of a data disruption more than just an IoT disruption. And then finally, the biggest one we might spend a little bit more time with is this idea of digiceuticals now tying to digital therapeutics. And that's called DTX or PDTX. One is prescription-based digital therapeutics, and the other is over-the-counter digital therapeutics. And remember, with IoT, you have the device side and the technologies that drive that, but IoT also is a broader concept for digital disruption and the idea of what that data is and how you're going to be using that data. So what is it? When we think about ourselves, our eyes don't see and our ears don't hear. Our eyes pick up light waves, our ears pick up sound waves, and it's our brain that gathers what it is and how to be interpreted. IoT sensors grab information in places that we weren't able to collect that information before, and then gives it to you in real time and gives it to us an ability for us to utilize that information quickly and effectively. Now, the flip side of IoT would be the internet and the ability to gather data from the internet and utilize that to provide value out to people. So you have the physical side of IoT, that's the actual sensors, and then you have the data side where you're gathering information in most cases from the internet. So we're going to talk through those two things. But on the IoT side, we got to realize that what we're looking at is where and why can we put a physical footprint, a data footprint on something. The reality is we're able to do almost anything related to that. Although there are some space issues and some processor issues that we're going to get into. But with IoT, as you're thinking about it, as you're looking at your strategy, as you're thinking through what it is you want to do, that's the key. The focus should be on what you're trying to achieve. The focus should be on what you're trying to collect. And then what can you do with that you're collecting? What value is it going to provide? The IoT on beds is significant now, where they're being able to register sleep patterns through the app based on how you're setting the bed up, based on other situations in that bed environment. The Apple Watch, powerful IoT watch that's giving you oxygen levels, heart rate, how much you've walked, it's a step thing, but so much more that it's going to be able to do from a health perspective. So great concept. Wear it, health support. Sleep, understand your sleep patterns. But there are other places that we can put IoT devices, and then is there value in that? So you want to be looking at this from an ROT perspective, return on time, and then a return on investment, an ROI perspective. And then how can you latch on to things that are already there? So Revive, for instance, moved away from the hardware side of its device and is utilizing someone else's hardware device. So that saves them manufacturing costs, but they're still creating the value that they can in the space that they're moving to. So it's an ecosystem. The thing about IoT, it's not a one-stop shop. It's not going to say, I want to do voice over IP. I can just call a cloud vendor over my phone. I don't want to do marketing automation. I can get this marketing automation tool sent to me. To do IoT right, you have to put multiple systems together. And I'll show you that in the upcoming slide. And you got to cross over stovepipes, which we know in IT and IT-related environments can be very difficult. So you just can't say, hey, I'm going to pop this in. The other problem here is that we have an issue with silicon. And you know that the chip shortage is already out there, and that's one of the limiting factors that we're dealing with. But we got to be looking at our processors, especially at the device level, and then especially at the data crunching level. How strong are our processors? How small are our processors? What's the heat displacement associated with the processors that we're using? So as you see this grow, you realize that it's just like the iOS model, layer 1 through layer 7. There's solutions at every level of the iOS model, all the way up to that level 7. And then, of course, the joke was back in the day, I'm now talking about the late 90s here with the layer 8, the political layer. And what I'm going to talk about with layer 8 is going to be not the political layer, but the core layer for me which is, what's the business model? What's the business outcome? What's the value associated with it? And don't get hung up on if you're an internal organization trying to utilize IoT and then data and digital disruption internally to maximize efficiency. It's the same thing. It's just that your customers are internal stakeholders instead of external stakeholders. So this ecosystem is very important and something that people forget. So as you're planning and thinking about an IoT strategy or a digital disruption strategy, realize that you have to look at it from a layer perspective, layer 1 through layer 7, already thinking through the layer 8, the thing I just created here, around that value layer, and then understand that there's going to be a use of some existing architecture and then some new tools and new technologies that you're going to have to bring to bear. You start looking at this ecosystem, start thinking about the shipping world and IoT and the shipping crates and what elements are in those cargo crates and where have they gone and where are they going? And then the ship itself, where is the ship at? What's its speed? Is there going to be delays in that ship getting to port? You think about that and you think about the ecosystem tied to that and the technologies, from the sensors on the containers to the sensors within the containers to the satellite system for your data, and then what system is actually crunching that information in the cloud. So you start seeing the fact that this is an ecosystem. I can't pound that concept enough as it relates to your plans in digital transformation and IoT. Remember, part of this presentation, ideas, thoughts, don't hesitate to chat in your questions, your comments, your ideas as it relates to this topic. So,
yeah, and David, we have a quick poll. I'm going to
all right,
up here.
Love it.
All right. So feel free to participate. Which best describes the main reason your organization is leveraging or planning to leverage IoT? Just to get a feel of the room. All right, continue.
All right. So no business model is safe here. None. You have the entertainment industry, which is getting blasted right now. Content distribution. Whose network am I going to distribute on? What's the cost associated with that? Who's watching? How they're watching? How does that change the content I'm going to develop? Now the business model is getting to a price sensitivity in the entertainment space, and we're seeing that with the mass exodus of subscribers from Netflix. And that really has to do with a price point issue. They reached a ceiling where the value of the product is diminishing based on the price point. Now they're trying to change the business model. Well, they'll give you a lower price point if you get commercials. Now, that's just like going back to broadcast TV. So digital disruption is such a challenging environment, not for the tech, although tech is important, but what's the business model and how is that business model going to be adjusted and changed? I mean, the marketing and sales world has been blown up because of the ability for people to search and look at and understand your product even before they contact you. Where back in the day, you had to actually contact them aggressively for them to understand what you have. Now they're looking at you and they only want to talk to you when they're ready. So you have to have automation and sensing devices to track them when they're on your website, to track people related to what type of campaigns they got and what type of messaging are you sending them. And also, and that big element here is the idea of relevance. When you're thinking about your digital disruption as it relates to your customer, your end case is, what is the relevance? How relevant can you get that messaging? And it's interesting on some of the poll questions here, modernizing the brand, absolutely critically important, because, if you're a client server based brand, if you're a brand that's really focused on selling a hard product, there are going to be disruptions associated with that. If you're a brick and mortar sales company, I know that's been a word that's been used for 10, 15 years, but you can continue to see the disruption that's going on there. So I love this idea. And then breaking into 2 new markets, that's what that's what this stuff does. That's what IoT does. That's what digital transformation does as well. One of the most powerful areas that you see digital transformation in is the banking world and the competition associated with what type of information they can provide you, how quickly they can provide it for you, and then is that a value attribute for you to move banks or stay at the bank? Because of course, we don't realize that, but the number one source for money that banks invest are our deposits. And they're always searching for new deposit mechanisms. And because of the reduction in the physical need for that, bank, that physical bank, now we really don't have that place to do some IoT work. So you got to do that work in the cloud, watching behaviors and activities in action. It would be pretty amazing if the banking world stayed the same with the branch and what type of IoT sensors you could put in that branch for collecting of information. I think one of the most powerful ones would be length of time online. But that length of time online, I just got my haircut yesterday, and Great Clips, you could see where I'm getting my haircut, has that tool where it says what your wait time is. But the problem is somebody has to put that information in. It says 0, I get there and it turns to 34 minutes, then it turns to 15 minutes as the person is moving people around. So that's another area of IoT that we have to look at, and we talked about it with Waze, is it self-generated? Is it information that we're actually typing in, or is it real information coming from another source? So as you've seen, I pounded this topic significantly, but my hope is when you come out of this presentation, you're really thinking more in terms of business model, not just tech. The business model of how you go to market, or the business model of how you serve the internal customers that you have. So if I had a vision statement, IoT impacts technology, but really it's all about people. The tech is the trees, but you need to understand the forest. What do the trees do to make that forest go, if you will, or make it grow? And then as you're an IoT professional, what are the vendors? And we'll talk about those. Your distributors, your disties and your VARs, how do they fit into it? What solutions can they bring into the table based on their partnerships? And then how can you get VARs or disties to actually work together, especially value-added resellers and the firms that most value-added resellers also have the integrations. So can different value-added resellers also support and work together when you're going across that whole spectrum? So you want to be thinking about that. But ultimately, if you had a look at this, you have all the wearables, the beacons, the sharing, the virtual reality, and training. Virtual reality starting to get hot, but there's pros and cons associated with that. Ultimately, you get to that center of why. Why are we doing this? So you wonder why you have challenges in trying to drive these new business models. Well, really what IoT does is it transforms technical problems into adaptive challenges. A technical problem is, I know what the issue is, I bring in the right resources, I manage that, and the outcome happens. And then I might have problems because I got the wrong resource or I'm out of scope, but I can bring that back in scope, I can make it happen. An adaptive challenge, as we'll get into, there is no real understanding of what you're going to do. And on top of that, once you kind of get an idea of what you're going to do, you really don't know how you're going to accomplish it. You have to test. You have to test to figure out what is the way to accomplish what you now figured out the need to be. And then ultimately, you have to test to figure out the need. And the best example of this, and Laura is on the call with us, is Revive. Revive was a venture capital-based startup for the wearable technology I talked about. So it had the device, it had the software, and it had the data. Device, software, data. So we initially tacked it on the need of the device in solving the ADHD problem at a parent-child level. So our marketing and sales go-to-market was associated with that. But what we were trying to do is learn. And the first learning was the data we were capturing associated with how much of the device help? How do they use the device? And one of the things that we found out, although in the research customers said they'd rather have a nice looking device over having to charge it once a week, the reverse actually happened in reality. One of the biggest challenges with the device is to get that type of power. It had to be charged. So we're learning. And as they're learning, they're pivoting. Now, does the data become more valuable? 10,000 people that are now included into the database on activity and trends associated with ADHD children. Think about that for a second. It's pretty powerful. Now, after that, you can start thinking about the therapeutic side of this device. And if the data shows improvement, how then can you move that to a diagnostic or a therapeutic device? All that trend took learning. The challenge is that it took a lot of money to go through that learning cycle. What we want to do from an adaptive perspective is find less expensive ways to test what those opportunities are, and then be able to put those tests into actuality once we got a better understanding of what it is that we think we're trying to solve and how we're going to solve it. And one of the best examples of a adaptive challenge I can give you is work from home. Before COVID, work from home was an adaptive challenge because you're dealing with mindsets in adaptive challenge. Like when you go to IoT, why? We've already done it the other way. Why would we want to do it this way? I don't think our customers are interested. I don't think our customers are interested is the kiss of death. And I've been a product manager for 25 years, and I talk about this all the time. Customers don't know what they need. It's great to get an understanding of your customers as it relates to updating your current product, making adjustments in your current product, but as it relates to agile market entry and trying to figure out where to go, your customers are not a great source of information. You got to go and figure out from an adaptive challenge perspective where the people are that may want that new thing. So this adaptive challenge, you have to deal with mindsets, you have to deal with existing processes and systems. And this work from home situation before COVID, certain people could work from home, certain people got the technology, there were rules around it. You had presence systems, so we had to make sure that you were there or else we weren't going to let you work from home. And then poof, COVID happens. And when poof, COVID happens, work from home becomes a technical problem. Give you the devices, give you the systems, give you the bandwidth. Now just go work because I need you to work. Now, as we pivot back to a potential post-COVID world, what are we seeing? The return to work concept. Now, that's not just for the workers themselves, but it's also for the leadership because they haven't changed their mindset. Now, that's around work from home, but think about it as it relies to business models. And so I've given you some of the adaptive examples, and you'll get this slide deck. But one of the things you want to look about is that on this is requires that number 2 requires changes in values, beliefs, roles, and responsibilities. This is the hardest thing. I mean, when Netflix moved from CDs in the mail to the streaming service, they had to change their staffing. They had to change their expertise internally. Then when they moved to content over just the streaming side of things, they had to add new capabilities, new talent. So we have to realize that number 2 is so important in the digital disruption, digital challenge space.
All right, it looks like we lost David. Something must have happened with his computer. So if you don't mind hanging on for just a moment, he's coming back. Right. Apologies, everyone.
I'm back.
And he's back. All right.
I'm back.
Okay.
Yeah, sorry about that. I think I hit the wrong button. So the state of IoT is really exciting right now. In 2022, The projection is 14.4 billion connected devices. That's 18% increase over last year. The projection in 2025 is 27 billion connected environments and connected devices. The top 5 or top 3, top 4 are Intel, Microsoft, Cisco, Google, IBM. So these standard bearers of technology are now coming to play in the IT environment. There's a lot of growth in the low power wide area and the narrow band IoT for the sensor side of things. So that growth is going to allow for putting sensors in places and manufacturing floors that don't traditionally have that strong local area network power and have difficult access to wide area networks. So that LPWA and the NB IoT are becoming very, very, very important from a growth factor on the device on the what do you call it? Sorry, the sensor side of things. And the biggest problems we're seeing is a chip shortage. The chip shortage is a very big challenge. And then here in the US, the other challenge is, the move to 5G and how fast and rapidly can we make that 5G transition so that we can start looking at getting faster speeds in those manufacturing places where you have the software-based industrial IoT, where the software is talking and updating and sending information out, and the sensor-related data as it relates to the processes, the system, how things are working on the floor itself. So the state of IoT post-COVID is hot. And a lot of that's being driven by the use of the low power LP wide area networks and the use of narrowband IoT from a communication standpoint. So you're getting some interesting adjustments in that physical layer technology stack, which is very helpful as it relates to moving forward in IoT. So the stack itself, at that component level is where you have your processing, your speed, your chip issue, and the device level. And that's where we still have to see changes and updates in technology around the idea of heat dispersion and heat itself. That's where you're getting the silicon tighter, you're getting it faster, but your processing means a lot of energy, and then that energy creates heat. So how do you control that? Think about your phone. Think about how powerful this phone device is and what it can do. I mean, I think about this compared to the gateway computers I was installing in training centers in 1995, and it blows your mind. But the reason this works is because of heat displacement. You hear the stories about how some of the Galaxy phones caught on fire. I think it was a Galaxy 7. And you realize that as you want to get components smaller, there's that challenge there that you have to be thinking about. Then the bandwidth area that we were talking about, that connectivity, that's a major challenge from an industrial and a city perspective. Now you have Elon Musk's satellite system that he's utilized and that he utilized to support the war in Ukraine, which can become a very powerful tool as he brings that online for very remote manufacturing sites and operational sites. But until that goes full steam, we still have this power challenge with transitioning to 5G, this problem associated with how do we get that much data through the pipe. Now, when you get there, now you're going to get into the processing system. See, IoT is so huge. Now you're getting into unstructured and structured data. You're getting into systems like Spark, Hadoop to process that information, then the mining tools, and ultimately the applications to give you that value. At the end of the day, Revive technology has become an application technology with a huge amount of power inside the app that on somebody else's wearable device, and then how that is tracking information and then sending that information out. And currently, I don't know what adjustments they made, but before it had to be a wireless local area network that could pull that data in because of how much data it was. Now, at some point, could that be processed cellularly? That's one of the things you have to look at. And then when we get into that insight stack, this is where we're going to start in the platform stack. This is where we're going to start talking about AI and ML, which we'll get into as we go forward. So when you look at this, number one, are you utilizing the internet to pull your data so you don't have this issue of connectivity, device, and component? Or are you needing that device level and component level technology? That's what you have to be thinking about. That changes, how heavy of a physical layer and layer 2 and layer 3 challenge you have. Then, regardless of whether you're using the internet or the physical side of things, you all have to look at what your platform is, how you're processing that information, what type of analytics you're getting out, what type of tools you're using, and then how can I make business decisions with that information. Again, love questions, love thoughts, love ideas. If you have anything in chat that you want to talk about, dig into, please don't hesitate to throw that out. Throw it out to us and share any type of information you want to share. Now, this slide is a great slide to take back. We could probably spend 30 minutes on it by itself, and we're not going to do that. This is a good slide to look at the industry, but what I really want you to be thinking about is that management and that security. Those are the one-stop shop solutions that you can dig into to cover all the rest of the community or village and ecosystem we were talking about. And remember, as I was talking about on the physical side, you have the WAN connectivity, the edge, the field connectivity, the device, and the component. But then if you're getting into just the data through the internet, you have your cloud, you have your platforms, your insights and analytics, and then finally, those services that you are bringing out. And I want to make that clear, even though this is an IoT presentation, you can actually consider the internet in some ways an IoT device and what it's collecting at the points of our phones or our computers itself, because this is an IoT device, especially from a geolocation standpoint, especially with regard to the activities we're doing with tools like Yelp and check-in tools that are being utilized. You can mash that data up to really be able to figure out and offer very relevant solutions depending on how your software is pulling in that data. So this is the slide. This is the map and picture of your digital transformation. I mean, scary to say, but I could do the entire presentation on this slide. So, business models. What are you doing and why are you doing it? I talked about the Revive business model dilemma. Selling the devices, selling the data, offering it up as a digiceutical, the idea of offering that healthcare data. So initially we started by selling to the device and rolling the data in for free, then trying to cheapen the hardware device and front end the data and the value of the data, then increasing the price of the device. But what we kept seeing as a business model, there were issues in that related to trust, because it wasn't FDA approved, related to the value that parents had in solving that problem, rather have a pill or just let it go instead of the work that the Revive device required. And then ultimately seeing the improvement though, and how to adjust that business model accordingly. These are things that people struggle with, especially in more mature industries. How far will a customer go to research online, like Carvana? Carvana still blows my mind. How much data can you really gather to successfully price a house, and some of the problems that Zillow had associated with that? And does that business model does it have longevity? Even the Amazon model, you can trade stuff, you can take stuff back through Kohl's. So there is that still physical element that provides value back. You just can't say I'm going to trash the physical element of the solution. So you have to be thinking about those. And because of that, you can globalize fast and effectively. E-learning and training, globalize it fast. English language, we're lucky, is the predominant business language. So we have that digital capability to go from offering a class just in the US be able to offer something across the world, because even a live class done virtually still has the time constraint, event-based scenarios. I mean, there's so many opportunities here that you have to re-look at what you're trying to do. I have a great friend who built a business model on going to eBay, pulling down really need to have products, and then pulling those products down and then offering those products to people who had very large, telecom systems that they couldn't change out. I tease him because he's like the Fred Sanford of the telecom parts industry. And he inventories those parts. He uses SEO for people to find these specific parts. And he's able to create a fantastic business model off of that. So now your operational processes, this is where you can start looking at efficiencies. You can start looking at, changes in how you attack things. This is also where your marketing systems come to play, your marketing automation systems, your Salesforce automation systems, how they connect in with LinkedIn. This is where your project management systems can come to play, and how you're pulling that data together to see if there's any trends associated with what's going on. And then finally, the customer experience. You built your business model, then how is the customer really attacking that? And this is where the testing should occur. This is the where you can try using design thinking, where you can try to use service design, lean startup to figure out what your customers are looking for, looking at. And the world of CX is a critically important world going forward. I think people aren't putting enough energy around that customer experience first and foremost, then adjusting and adjusting their business processes, and then adjusting their business models based on what customers are looking for. Not just their existing customers, but those customers that we're looking to touch. And then with your existing customers, asking the right questions. There's a lot of great work going on with CX. And then, of course, as we know, CX drives to UX, because most of the activities that we're talking about drive in the cloud and from the internet. So the entire IoT story is data. Where can I capture data? How can I capture data? Then the insights I can dig out from that data, and watching out for the false positives and false negatives as it relates to understanding that data, and watching out being tricked. And more systems are being tricked these days. And then finally getting into decisions, the decisions that you can make with that data, the whys, and then how you can react to those whys. How you look at correlating different scenarios and seeing a better picture that you can attack the marketplace. That Revive story is completely that. Learning that the only way they're going to get to the promised land is by offering it as a therapeutic diagnostic. The doctor forces them to use the product. The parent on their own, there's not enough of them that would engage. They want some type of medically approved device. Understanding this, you understand IoT, but there's a lot of depth as it relates to that insight perspective. So why is data special? First off, there's no transactional limit. Gather it, gather it, gather it. Storage is so cheap. It's basically free. You can keep gathering data. Keep gathering data. There's no transaction limit. Then you can use that same data across so many different areas: accounting, marketing, sales, operations. That same data can be used across multiple disciplines at multiple times. And finally, data appreciates in value. It doesn't depreciate. Especially data related to trends, not marketing data like location, email address, that depreciates. But data related to activities, it consistently appreciates. And you can mash data sources together to create even more value. And there's so much power with data. And what we have to think about with us humans is our problem is we have a limit to how much data we can actually capture. And that transactional limit causes us to really require this to make very complicated and complex decisions. It requires us to pull this data in. But the problem is we need systems by which can process that data to give it to us to utilize our best skills as it relates to how do we make decisions off that data. And we have to realize with us, we have mental distortions, time biases, and effective forecasting biases that even if we process that data, we don't have this. We have these distortions that cloud the actual information the data provides. So what we really want to look at here is how is AI possible? So what we want to say is, what are the tools to provide us deeper insights outside of one-dimensional tools that can help us make decisions going forward? So of course we need that data, and we're finding new ways to capture that data, new systems to pull that data in, new locations to capture that data, and the cost of holding that data is getting cheaper and cheaper. But now we have the problem with computing power, software, the computing power to run that software, to start looking at how can we utilize that data more effectively. So when we look at AI, we don't have true AI. We don't have cognition. We have the ability for machines to learn. Some can learn with less teaching, some can learn with more, some learn with more teaching. That's what we have to look at it. But this is not Skynet. This is not Legion. This is not Vicky. We are not at that stage, although some people talk about it and get very scared. We are at the stage where we can help us, we can get a system to learn, and with the processing speed, it can see repetition, patterns, trends. It can make predictions, and those predictions become tighter and tighter based on the processing power and the learning that system is doing. And then this gets into the idea of supervised versus unsupervised AI, specifically around machine learning and what you want to be looking at and what you can let run in the wild as it keeps learning. Us humans, we think deeply, but we think deeply on a little bit of data that we can store, but we have tons of context and subtext, and we can answer that why question. So we have that art. Our brain has that art. What the machine learning and AI can do for us is it provides the idea of processing tons and tons of data. It can show those patterns. It can show those trends. It can do things based on those patterns and trends. But it's science. It predicts, and it's not going to tell you the why. So where we're at is really on the cusp of utilizing machine learning consistently, and then trying to get deeper into deep learning. And people call AI. They have this AI system. A lot of times it's still just basically a simulation. And the simulation doesn't learn. The simulation has 1,000 permutations, 1,000,000 permutations, and it feels like that's learning, but it's not. It just has hard set permutations that takes you down a path. And there's still a limited number of paths that can be taken. So you got to watch that when someone says it's AI, but it's really a simulation, or it's really still doing high-end pattern recognition without that adjusting and that learning off those patterns. What we really want to be getting to ultimately is that deep learning side of things. But before we get there, I want to talk about Revive one more time. And this time I want to talk about it by the machine learning aspect. So it had an accelerometer. An accelerometer, you can look at movement. And what we were trying to teach the system is to figure out what a fidget was. So we had, using Google's tools, we had children sitting at a desk doing work, being videoed, and then teaching the system, saying, okay, when the accelerometer is doing this, that's a fidget. And the tighter the accelerometer, whether it's a 6-point accelerometer, you can start seeing a hand movement. You can start seeing a shoulder movement. You can start seeing a back movement. From that, the machine can get tighter and tighter, learning about associated with that movement, and then how that movement correlates to are they attending? Are they saying they're attentive when the watch vibrates? So you have to teach the system, and then the system, you have to further teach the system and further teach the system. system. So that device was working on machine learning. Lots of data, lots of the idea of machine learning and the idea of how much data we're giving to it, and less about the algorithms. So you had to constantly teach that system. But when we get into deep learning, much less teaching, a lot more models and processing. So less feature engineering, more models and processing. We're not at deep learning yet. It requires too much processing speed. It requires too much in the way of algorithm development that we're not there yet. But when you get into deep learning, the system is definitely learning at a faster pace, but it's still not telling you why. It can adjust activities accordingly, but it doesn't know why that is going on. And it's still not making the final decision about what to do with it and how to do it. You have to tell the machine, all right, these are the things I want you to learn, and it begins to learn with tighter and tighter fidelity. With machine learning, it's a lot more hands-on telling and teaching. With deep learning, it's less hands-on, but a lot more processing power. Do you have the right algorithms to do this? Now, when we see this picture, the thing that scares me the most is it still requires those data inputs. And one of the things that I could see happening is data can lie. People can lie. Systems can lie. Just like you could do a denial of service attack on a computer system and block entry, there could start becoming attacks as it relates to AI systems, providing it misinformation at a large scale and having it doing things that it shouldn't be doing because it's registering that misinformation. Because it's not looking at that data point as if it's correct or right. It's looking at it as a data point to put through its learning process. A kid, for instance, could just start shaking their hand with the Revive device if it knows it, just to trick the system. Or it could, or you could try to stand still more to trick the system. And if it's a therapeutic and diagnostic, that could protect you from having to take medicine. So you get all these interesting little puts and takes associated with it that can be really powerful. But you have to understand what's available to you. So if we go those couple slides back, right here, that insight scenario, that's where your AI, that's where your machine learning capabilities are, and getting away from those predictive systems or the simulation systems to actual learning. So we got some key statistics here, which are pretty powerful related to where things are going. The IoT spend isn't going to be above $1 trillion. And just in Q1 alone, the VC acquisition money was about $1.2 billion. So we're seeing people put money into this world, both the hardware side of it and the software side of it. But what's happening? Ultimately, technology has this virtuous cycle. They feed off of each other. We have applications, but then we need infrastructure to be able to drive the value of those applications. We have more applications, and then we need infrastructure, where the infrastructure catches up, so we need to get better applications to utilize that infrastructure. And really, we stand at this evolution, at this 3.0 concept. And I think from what I see, it's going to be more of an infrastructure challenge at this point. And this is where companies like NVIDIA and what they've been doing, both from a stock market performance and a technology performance, is pretty powerful, and really focusing on the car side of things. How can we update the processing capabilities than just doing the low powered wide area and the narrow bandwidth wide area? Where can we actually increase our bandwidth to be able to grab that information, increase the processing speeds to do better deep learning processing and build those multiple algorithms together to really possibly pull out some corrupted data? We don't know, but this is a map that you want to be thinking about as you look forward to where you can go, because in this environment, the status quo is the invisible killer. You've got to remember that in IoT and digital transformation, the status quo is the invisible killer. So understanding where this 3.0 is going and how it's going is critically important moving forward. So the size of this, it's everyone. It affects you both in the utilization of the systems you have and how you do your job and what you get from people out there. And then here is some looking at job possibilities. And you can see up here, data scientist, data engineer, human resources analytics, especially getting into the whole LinkedIn side of things, trying to find proper talent based on the talent challenges we face in today's marketplace. How can you use analytics from LinkedIn and other sources to be able to pull higher qualified people in? You know, being able to utilize remote labs to test people's skills. And, you know, that's one of the areas that, you know, Cloud Institute is really trying to go into, is that skills validation side of things, to quantify that the person has those skills. And really that data science, data engineering piece of this is extremely important. Those are the new jobs. A lot of the physical layer jobs are going to be skills updates. But these are the brand new jobs that are going to be growing in need around the idea of how to process and utilize that data. So I'll close out with this slide. Our experience can be a noose around our neck. Our experience tied to the way we operate, how we operate. In the IoT and DX environment, we really have to learn how to unlearn. Do you want to go to that doctor who hasn't unlearned the old ways to find and figure out those new ways? Our experience, as I said, can bring us down. You have so much in your bucket and you're trying to fill it up because you're trying to keep pace with, keep the things you know, but still try to keep up. And I've learned this over the course of 3 to 4 years, and that process of trying to keep an open mind to learn. So how do I unlearn? And there's a great book on unlearning. Barry O'Reilly wrote it. I'd highly suggest it. And then you'll get the slides after this presentation, but we talk about adaptive learning and how to get yourself in that productive distress place where you're comfortable being uncomfortable, and then ways to stay comfortably uncomfortable, and then your learning amplifiers. And then derailers to learning, the busyness epidemic. You can't be busy all the time to attack IoT and digital transformation. You have to give yourself time to think and places to think. And with that, I'll end with any questions or thoughts or comments. We had a good number of people sticking out for the whole time, which is great. I appreciate that.
Yeah, thanks everyone for joining. We don't have any questions in the chat, but there's a lot of new information in here for me, David. Where does one start?
Well, I pulled up a slide. There's 2 things I tell people to go to. First, there's a great website called IoT Analytics. And the IoT Analytics site has a lot of great information. I just dug it up here the other day. I was really impressed with it. And then you can go to a place called CertNexus. And CertNexus has a lot of really good certifications that can help people start. IoT and business certification is a really powerful certification for the stuff that I was talking about. So I think those are 2 really good places to start. And then from a business model perspective, one of the people I think does a really good job on this is in the book, David and Goliath, Malcolm Gladwell. I think Gladwell does a really good job of talking about different business models and how to start thinking about business models differently by, fighting through some of your cognitive distortions that causes us to stay in the same box. That's a whole nother presentation.
Well, we'd love to have you back for that.
Well, any other questions, Tom? Oh, Laura loves the book, David and Goliath. Yes, so do I. It was amazing.
Okay.
Hey, Tom, thank you for the great job. I appreciate that. Sir, no questions? Laura, those are 2 great questions.
All right. Well, we will
give people 5 minutes back in their life.
Yes, thank you all for joining. Just as a reminder, this presentation, the replay will land in your inbox. If you have any questions, my email address, jana.finch@cloudinstitute.io, is also all over your inbox. Feel free to reach out if you have questions about this presentation or any of our training. Thank you all. Have a great day.
Thank you all. Goodbye.